Good day, everyone. Our project is Intelligent Elevator System. So, what is an intelligent elevator? Elevator is a type of vertical cable transportation machine that lifts people, heavy equipment between floors, levels, or decks of a building. The intelligent elevator system is a simulation of an elevator system that will open or stop when it reaches a floor level. The system consists of 5 floors to be passed through. It is more useful in different ways to lift objects and users in different heights is what is always needed in industrial and constructional works. This project simulation is a rising edge trigger clock. In this slide, it shows module file of the VHDL code of the elevator. It contains all of the input and output of the codes. It also contains the process of the codes. The slide 3 contains ports and signals of the code. The first process is all about clock system in the elevator, and the next process is the counter that counts the floor and the up and down of the elevator. The last process involved in this slide are two values of the elevation of the system, wherein there is the standby mode and initial mode. In slide 4 and 5, you can see the flow of the elevator and also the value of the elevator every time it moves. The CP stands for current process and the NP stands for next process. And lastly, you can see the 6 statements that represents the number of the floors. In slide 6, you can see the test bench file of the module file. It contains the values of the inputs, and this can also show you how to process works in module file. In this process, inputs and outputs must be redeclared in order to process. In slide 7, you can see the import of the module file in the test bench. UUT stands for Unit Under Test. It imports the module file in the test bench. In slide 8, you can see the declaration of the values in the input because it is fully automated. In slide 9, it shows the output waveform in 0 nanoseconds. It describes the behavior of the elevator when there are no inputs or the elevator is in idle state. In slide 10, it shows the output waveform of the first floor increase. As the figure shows, the idle state became 0 or low, and the elevator 1 or floor 1 signals on high state. In slide 11, it shows the waveform of the second level of an elevator, wherein all of the signals are in low state except elevator 3 or second level. As described on the discussion portion, the signals are high when the clock is on a high state and rising edge. In slide 12, it shows the waveform of the third level or elevator 4. This will only occur when the signal of elevator 4 is on high state. Other signals of the floor levels are in low state. In slide 13, it shows the waveform of elevator 4 or the fifth element of the array ELEV. This describes the waveform of the fourth level increase. In slide 14, it shows the output waveform of the simulation of floor level 5 increase of an elevator. Fifth floor is represented by elevator 6, wherein it is on high state and the other signals are on low or off state. In slide 15, it shows the full waveform of the whole system of the intelligent elevator. This figure represents all of the systems and variables of an intelligent elevator to function, like clocks, floor levels, floor states, and the flow of the elevator. Either it is on an upward motion or downward motion.